Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Tasbir's math tutorial class presented by Muhammad Tasbir Karim. Today we are going to start the class of 9, chapter 9, trigonometry ratio, exercise 9.1, part 2. So, first part I just solved some maths of this chapter, and now we have just finished this video rest of the maths of this chapter. So, I think you understand the first part of the video, and you can solve now all the maths of the chapter up to 13. Now we are going to start from 14. So before solving the maths, just this is the formula you have to memorize. On the last video I told that you have to memorize this all those formula. Here just repeat again: cos theta equal to 1 by sin theta, sec theta equal to 1 by cos theta, cot theta equal to 1 by tan theta equal to sin theta by cos theta, cot theta equal to cos theta by sin theta, sin square theta plus cos square theta equal to 1, sec square theta minus tan square theta equal to 1, cosec square theta minus cot square theta equal to 1. So now we are just going to solve the maths. We are just going to start from today 14 number maths. You can see on the screen 1 by cosec a minus 1 minus 1 by cosec a plus 1 that equal to 2 tan square. We have to prove it. So here is the solution. The left hand side you can see 1 by cos a minus 1 minus 1 by cosec a plus 1. So here we just subtract here. So you can see the denominator are not same, not alike. So we have to multiply for finding the LCM. So this is the multiplication: cosec a minus 1, cosec a plus 1, and as there is a missing cosec a plus 1, so it will be in the numerator, and minus here and cosec a minus 1. I think you understand this algebraic addition subtraction. So I think if you understand, it is very easier to you. Okay, the next line, just a withdraw the bracket. So here is a minus sign, so minus cosec a plus 1, because this minus is multiplied with this positive cosec a, that is minus cosec a, and minus minus plus, that is 1. So if you cosec a gone, so there will be 2 in the numerator, and cosec square a minus 1. So the formula of cosec square a minus 1, that equal to cot square a. This is the formula. You have to learn it. Otherwise, it is very difficult to solve all this type of math. So 2 by cot square a. If you separate it 2 into 1 by cot square a, you can write 2 tan square a, where 1 by cot a equal to tan a. So this is your right hand side and proved. I think you understand. I'm just going to the next math. I think you will understand better. So here is the next math, number 15, sin a by 1 minus cos a plus 1 minus cos a by sin equal to 2 cosec a. So here is the solution. Left hand side is sin a by 1 minus cos a plus 1 minus cos a by sin a. So if I just, as you can see, there are two different denominators, so their product will be the LCM of this for solving this addition. So here sin a into 1 minus cosec a, so sin a into sin a, that is sin square a, and 1 minus cos a into 1 minus cos a, that is 1 minus cos square a. How we are going to do that? We just last maths I told you that there are two different denominators, which one is missing, we have to multiply with that one. So here is sin a missing in the denominator, so we have to multiply with the numerator, sin a into sin a, sin square a, and here also 1 minus cos a is missing in this part, so I have to multiply with the numerator, same thing, so the whole square. Now in the next line, sin square is remaining, that plus is here, and I just put the formula of whole square, a minus b whole square formula, a square minus 2ab plus b square. So here I am just arranging this sin square and cos square together in front, and the rest of the part is the right side. So sin square a plus cos square equal to 1, we know that, and the rest of the part is 1 minus 2 cos a. So 1 plus 1 equal to 2, and minus 2 cos a, and denominator remains same, there is no change on that. You can see there is a 2 common of this numerator, so I just took it, and the remaining part 1 minus cos a, You can see the 1 minus cos A and 1 minus cos A are common here in numerator and denominator, so I am just removed it. So 2 by sin A is there. So 2 by sin A, we can write 2 into 1 by sin A. 1 by sin A means that is cosec A, that is your right hand side. So I think we proved. So I am going to the next math of this chapter number 16, that is tan A by sec A plus 1 minus sec A minus 1 by tan A equal to 0. So here is the solution. In the left hand side, I am just writing tan A by sec A plus 1 minus sec A minus 1 by tan A. So here is the math. I am just doing the subtraction here, as these are two different denominators like the before one. Sec A plus 1 into tan A. So tan A into tan A, tan square A, and minus sec A minus 1 into sec A plus 1. So the thing is here. So tan A into tan A, that is tan square A, and this is sec A minus 1, sec A plus 1. So A plus B, A minus B. The formula is here, A square minus B square. Now I am just writing here the formula of sec square A minus 1, that equal to tan square A, and you can see tan squared A minus tan squared is gone. So here it is 0. So 0 by anything is 0. So it is remaining that equal to 0. That is your right hand side. So tan A by sec A plus 1 minus sec A minus 1 by tan A, that equal to 0. So that is your proof. So here number 17, tan theta plus sec theta whole square equal to 1 minus sin theta by 1 plus sin theta by 1 minus sin theta. So here is the solution. In the left hand side, you can see tan theta plus sec theta whole square equal to I am just converting into sin theta by cos theta, 1 by cos theta. You know this formula. Okay, so here the addition, the denominator is same here. So I just write here 1 plus sin theta by cos theta whole square. So I just separated the whole square with the numerator and denominator. So this is 1 plus sin theta whole square by cos square theta. 1 plus cos square theta, you can write 1 minus sin. Cos square theta equal to, you can write 1 minus sin square theta. I just wrote it here, and numerator remains same. We know this formula. By this way you can just transfer it. Sin square theta plus cos square theta equal to 1. I am just sending this sin square theta to the right hand side. So 1 minus sin square theta equal to cos square theta. So instead of cos square theta, we just write 1 minus sin square theta. You can write, see, 1 square we can write that equal to 1 minus sin square theta. You can write sin theta whole square. So a square minus b square, a plus b, a minus b. So here in the whole square part, we can write the same thing together twice. So 1 plus sin theta whole square means 1 plus sin theta into 1 plus sin theta, and in numerator 1 plus sin theta into 1 minus sin theta. So if you simplify it, 1 plus sin theta and 1 plus sin theta, then the remaining part will be 1 plus sin theta by 1 minus sin theta. That is your right hand side, and I think you understand very clearly. If you are not understand, just few minutes go back and you will see this math again. I think you will understand. Now the next math number 18, cot A plus tan B by cot B plus tan A equal to cot A into tan B. So of this solution of this math, we have the left hand side cot A plus tan B by cot B plus tan A. I just transfer the denominators part by cot B equal to 1 by tan B and tan A equal to 1 by cot A. So if I do the addition here, then cot A tan B, that equal to cot A plus tan B. So if I just do the reciprocal, this part I am just transferring to the, that will be multiplication, and you can see cot A plus tan B and cot A plus tan B will be remain same, like this way. Just this one is just changed to, in upper part, cot A into tan B by cot A plus tan B, and this way just this one here. And so if you simplify these two part, it will be just on cot A tan B will be remain. This is your answer. So this is your right hand side, so left hand side equal right hand side proved. Now the next math 19, this math is a little bit bigger, but it's not so difficult, I think you'll understand. So here root over 1 minus sin a by 1 plus sin a equal to sec a minus tan a. So here the solution, writing the left hand side. So here is the left hand side. I just multiplied the numerator and denominator by root over 1 minus tan a. So this is I multiplied here. So you can ask me or you can just have a doubt. So which one you have to multiply? Why you didn't multiply with root over 1 plus sin a, as the both of the sign are there? We have to just think always the denominator part, we will not continue any root over. So for removing that, we have to multiply with the conjugal number of the denominator. So as this is the denominator, and what is conjugal number, you know, in my last video of this chapter, we multiplied once, that is here also I'm just telling, if the number the two term are same, just sign is opposite, then those are called conjugal number to each other. So 1 plus sin a, the conjugal number of 1 plus sin a equal to 1 minus sin a. As this is in root, so I just multiplied with in root. So if I just write here this way, so we will understand the same thing is there. You can remove it and it will be uh, remain same, it will not change anything. So for that purpose I am just multiplied with the numerator and denominator to keeping like alike from the before on. Again I am just telling you for make you more clear. There is a number, what is there, I don't know, I don't need to know. The denominator, what is the denominator here, that number, that's conjugal number. So 1 plus sin a, that conjugal number is root over 1 minus sin a. I multiply with numerator and denominator, so it remains same, because in the numerator and denominator same part we can remove it. By that way we can just multiply in the both part. So actually these are remain the last line which is in the above, so it is remain same, but we can go ahead if I do this. How or what is the benefits, you can look, these are same thing in there, so we will just write root over 1 minus sin a whole square, and here root over 1 plus sin a into 1 minus sin a. So this square and root will be gone there. So 1 minus sin a, you can see there is no root, and similarly 1 plus sin a and 1 minus sin a, there is 1 minus sin square a. So now you can see we can use the formula here cos square a. We know this formula, just last maths we show it, 1 minus sin square a, that equal to cos square a. So cos square a root over, we can write it just 1 minus sin a by cos a. So I think we understand right now. So here I am just separating this 1 minus sin a by cos a equal to 1 by cos a minus sin a by cos a. Now 1 by cos a equal to sec a and sin a by cos a equal to tan a. So this is, you know, in the formula. So that is your right hand side that we proved. So this is the next math of this chapter, number 20, number question, root over sec a plus 1 by sec a minus 1, that equal to cot a plus cosec a. So here is the solution of this math. The left hand side is written here. So here I am just doing the same thing. What is the denominator here? Root over sec a minus 1. If you see the root in the question, you can think the math can be solved like this way. So here root over sec a plus 1 by root over sec a minus 1. The conjugal number of this one is root over sec a plus 1. So I am just multiplying in the both numerator and denominator, multiplying both numerator and denominator by this one. Now you can see sec a plus 1 whole square and sec a minus 1 sec a plus 1. In the very next line you can see square and root is gone, so sec a plus 1 is there, and here sec square a minus 1. So sec square a minus 1, that equal to tan square a, root over tan square is there, so that equal to sec square a minus 1, that equal to tan square a. So root over and square is gone, just only tan a is there, and sec a plus 1 by tan a. So I can just write sec a by tan a plus 1 by tan a, which is cot a, but here 1 by cos a, I just uh, transform in the formula 1 by cos a, and tan a equal to sin a by cos a. So this is the formula. Now you can see from here to here, 1 by cos a into cos a by sin a, as these are in division. So in the just opposite, that is multiplication, we just write the reciprocal of the denominator. So this is the reciprocal, cos a gone. So 1 by sin a plus cot a, that equal to cosec a plus cot a. That is your just you can arrange, it doesn't matter actually, because in addition whatever that is okay. So this is your right hand side and that is your truth. So I think you understand, it's not so difficult, that uh, the question is a little bit bigger but not actually so difficult to understand. So I'm just going to the next math of chapter number 21. Now we have to set some information are given here. If cos a plus sin a equal to root 2 cos a, prove that cos a minus sin a equal to root over 2 sin a. This is a very important math for SSC examination. You will see this type of math or in CQ part, and sometimes some modification is there available in the question, but actually this procedure is very common for solving in any question. Okay, so you just understand, try to understand, it's not so difficult, but sometimes in the exam time or exam period we forgot the all those rules, actually that is the problem. So here given, that is cos a plus sin a equal to root 2 cos a. So we can write just the sin a is remain this one, cos a send to the right side. You can think why sir, why sin a will be stay cos a sin, because which part is here, cos a, that's why I'm just sending this cos a, because we can take a common cos a common. So the very next line you can see I just took common causes. So root 2 is here, minus 1 is here, and sin a remains sin a. I'm just turn over because in the next line I need to do that. So this one, this part I am just multiplied with the cos a, I am just sending to the right side, that is sin a by root 2 minus 1. Now I am multiplying with this numbers, conjugal number, with numerator and denominator. So multiplying both numerator and denominator by root 2 plus 1. So this is the denominator, root 2 minus 1. Its conjugal number is root 2 plus 1. So you can see, that is, if I multiply with this with sin a, then root 2 sin a plus sin a, and here root 2 minus 1, root 2 plus 1, a square minus b square. So root 2 square means 2 and minus 1 square means 1. So 2 minus 1 remain there, 2 minus 1 means 1, so nothing is there. So root 2 sin a plus sin a, that is remains. If you transfer this sin a to the left side, cos a minus sin a, that equal to root 2 sin a, which is we have to prove. So I think the steps of doing, there are lots of way that you can do that. You can keep it here in both side, you can multiply root 2 plus 1, it will be shorter your line, and here will be the formula a square minus b square, and it's remaining like that way. So you can do that way also. Lots of way are there, but end of the day the question is, this is very important math, so you have to understand, that is the thing. So you will just try to understand. Now the next math, number 22, tan a equal to 1 by root 3. Find the value of cosec square a minus sec square a by cosec square a plus sec square a. This math is also very common in SSC examination. In 9.2, this math is solved in another way. So here it's actually solving in different way. So here is the solution: tan a equal to 1 by root 3. So sin a by cos a equal to 1 by root 3. So we can write whole square. So here will be 1 square means 1, root 3 square means 3, and sin square a by cos square a, squaring both sides. Now I can write sin square a into 1 by cos square a, that equal to 1 by 3. Sin square a I can write 1 by cosec square a, and 1 by cos square a I can write sec square a. So now it will be stand like this: sec square a by cosec square a equal to 1 by 3. So now we do just turn over, that is called invertendo. In the chapter 11 you will see this type of math, invertendo, just altering. Okay, so I am just doing that. The numerator will be go denominator, denominator will come to numerator. So the thing is like that. So here the thing is happen if there have two sides, left hand side and right hand side together in a equation, we can do it. Otherwise, in any particular part of a maths or in just one term of the maths, we cannot do it. So it is actually we can do it in any equation. So here is the equation. So the numerator is gone to the denominator, denominator is gone to the numerator. That is called invertendo. Here is also the same thing, just altering, nothing else. So here I am just doing another thing of the part of a chapter 11. If you solve that math, I think it is known to you. Otherwise, it is a new thing to you. So this is called componendo and dividendo. So here is componendo dividendo what? So here is the numerator and denominator. In the numerator part, I will going to add it. So cosec square a plus sec square a, and in the denominator, the numerator minus denominator. Here also same thing, numerator plus denominator and numerator minus denominator. Same thing is done in the both sides. So it is actually a comparable things, or in proportionality is there. So in chapter 11, so by those method we just use componendo, dividendo, invertendo. Okay, so those type of things are there. So if you solve those maths, it is very easy to you. Otherwise, I think you will just try to understand numerator and denominator, numerator plus denominator, numerator minus denominator, that is together called componendo dividendo. So what is remaining? I am just do the invertendo again. So cosec square a minus sec square a, and cosec square a plus sec square a, and 3 minus 1, 3 plus 1. So here the addition of these two is 2 by 4. So the part, the question told you find out the value of this. So here is the value 2 by 4. If you simplify it, will be 1 by 2. That is your answer. So I think it's not so difficult. So uh, here is the another question, that is number 23. If cosec a minus cot a equal to 4 by 3, what is the value of cosec a plus cot a? It's also very common math in SSC examination questions. So you can see the previous board question. You will see this type of math up there available. So you will understand. Given cosec a minus cot a equal to 4 by 3. So we know cosec square a equal to 1 plus cot square a. So I am just writing the formula cosec square a minus cot square equal to 1. So a square minus b square, a plus b into a minus b. So here cosec a minus cot equal to what? 4 by 3. So I am just going to put the value 4 by 3. If I change to the side, then cosec a plus cot a equal to 3 by 4. So you got the value. Very easy math. So this is another math. If cot a equal to b by a, then find the value of a sin a minus b cos a by a sin a plus b cos a. So for the solve of this math, there is given cos a equal to b by a, or cos A by sin A equal to B by A. We know this formula, that is cot A equal to cos A by sin A. I just invertendo, I just did. Then I just multiply with A by B in the both sides. A by B in the both sides. So what is there? A sin A by B cos A, and here A square by B square. In the both side I multiplied by A by B. So in the very next line I am just doing componendo and dividendo, and the same thing I did in the number 22. So this is the numerator and this is the denominator. So numerator plus denominator in numerator part, and in denominator numerator minus denominator. The right side same thing, numerator plus denominator in numerator part, and in denominator part numerator minus denominator is called together component and dividendo. So this is the part which the question told you, that's why I am just inverting to here again. That means the denominator go to the numerator, numerator comes to the denominator. Here also the changes are there. So that is your thing, and this is your required A sin A minus B cos A by A sin A plus B cos A, that equal to A square minus B square by A square plus B square. So this is the answer of this question. So thank you for watching this video. This was the last math of this chapter. So I hope you will understand all the maths of this chapter. Practice them, practice them, practice them. Otherwise it is quite difficult to keep in mind when in the examination hall. So I think you will this video will be very beneficial for you. Hopefully you will understand all the maths, and one day you will be expert of trigonometry. Thank you for watching this video once again.